Hey, what's up, class? Welcome back. Another episode of Math 1 Learning. Hopefully, you're doing well, and hopefully, you have your notes in front of you ready to go. So, recently, we've been working on linear word problems, linear equations, and linear word problems. And recently, I taught you a strategy that I came up with. I call it the three-box diagram or the three-box strategy. So we're going to continue to work with that strategy, and we're going to go a little bit more in depth with linear equations and taking a look at those. So have your notes ready. I'm going to flip over to the DocuCam, and here we go. So to start, I have a question for you, and I may have covered this in class. I'm just putting this in the video for those that weren't in class. So my question is, what is this and how does it work? Now, most of you probably recognize this as a vending machine or a candy machine. And unlike a soda machine, in a vending machine, each of these items, or maybe even these rows, cost a different amount. So like in a soda machine, whether you're buying a Coke or a Mountain Dew or a Powerade, everything usually costs the same. It's usually like $1 or $2. But in a vending machine or a candy machine, each of these items has a different price. So you got your chips up here, and you probably have some healthy items in here, and then looks like maybe some different kinds of nuts or crackers, sunflower seeds, and then you've got your candy bars down here. And each item costs a different amount. So you have to put in a certain amount of money, and then you come over here and you push these little buttons. And the amount of money you put in will determine what you get out. So what you put in, you don't always get the same thing out. And what we're working on, these linear equations, are similar to a vending machine. Here's another diagram that I found. Think of these linear equations as what I call an input-output machine. So we're going to plug something in. In this case, we're plugging in the number 60. It's going to come down here. It's going to go into the machine. It's going to multiply by 10. And then we're going to get an output of 600. So we plug something in and we get something else out. Okay, so try to keep that in mind as we go through these notes today. All right, so let's go ahead and get started. And I'm going to pull up the first page of notes. So in our notes today, our objective is to explore a strategy for solving problems that involve a rate and a linear equation. And this strategy, I call it an input-output chart, an input-output chart. We're going to be using that three-box diagram in just a moment. Okay, so we're going to be exploring this strategy. So a linear equation, let's just review really quickly. Remember, a linear equation is an equation that has a rate. So it's got some type of a rate, miles per hour, or if you're, an example might be if you have a part-time job and you make $15 per hour. So a rate, and then it's an equation that has two variables. We're going to talk about those two variables in just a moment. All right. One of those variables is the x variable, and that's usually what we call the input variable. And then we have the y variable, which is the output variable. So, for example, in our little diagram here, if we were going to plugging in here, this would be our x variable because that number could change. We could plug in 60, we could plug in 50, we could plug in 300. So this is our x variable, and then over here our output is going to be the y variable. Okay, here's another example of a little input. Right, we're plugging in, and then it goes through the machine, and we get something out. Okay, so a linear equation has a rate, and it has an x variable, which is our input, and a y variable, which is our output. Now, just again, continuing to review, when we talk about a rate, remember a rate is a ratio of two categories or two quantities. For example, I mentioned this just a moment ago, a rate of pay. If you have a part-time job, you make $15 per hour. So the categories that are being compared are dollars to hours, right? Or money to time. So specifically dollars per hour. So we have two categories. So a rate always has two categories, and usually it's got this word per in there. Okay, so let's take an example. Look at an example of a word problem here. So we have Joe, and he wants to buy a mountain bike. All right, he wants to get into mountain biking, and let's see. It tells us he already has $200 saved. If he earns $20 for every neighborhood lawn he mows and trims, how much money will he have in total after he mows 10 lawns, 15 lawns, and 20 lawns? So the question that we're trying to figure out is how much money will he have in total? All right, and they give us a few different numbers that we need to work with. 10 lawns, 15 lawns, and 20 lawns. So he's trying to save money for his bike. Okay, he already has $200 saved, but mountain bikes are, especially the nice ones, are pretty expensive. They can get up as much as $1,000 or $2,000. So he's going to try and save some money. All right, so let's go through the steps. You've already kind of learned these with the 3-box diagram. So the first step when we're looking at a word problem is we're going to want to set up that 3-box diagram, which we will do in a moment. So our strategy is to set up a 3-box diagram. Okay. And then step 1, when we're setting up that 3-box diagram, step 1, we want to identify a starting amount or an upfront amount. What's the starting amount or the upfront amount? In this word problem, it tells us that he already has $200 saved. So this is a key word. He already has. Okay, so that's his starting amount. So Joe has $200 saved. All right. Then step 2, we want to figure out, is there a rate in the problem? Determine the rate of the problem. And since all of these problems we're working on right now are linear problems, they will have a rate. So determine the rate. So in this problem, let me pull the problem back down. It tells us that he earns $20 for every neighborhood lawn. So $20 for every lawn. Okay, so step 2, determine your rate. And in this case, it's $20 for every lawn he mows. Okay, then step 3, we want to determine the output total. Do they tell us a total? And in this case, they don't tell us a total amount of money that he has. We only know that he's starting with 200, but it doesn't tell us anywhere in the problem that he will finish with $1,000. It doesn't say anything like that. In fact, this is what the question is. How much money will he have in total? Right? So we're actually trying to figure out the total. We don't actually even know what the total is. We're trying to figure it out. So for step 3 down here, we want to determine the output total. This is the total money saved. We don't actually even know how much he has saved. So I'm going to put question marks because we don't know how much he's going to have saved. All right, so those are our 3 steps. Now let's go ahead and put those into our 3-box diagram. Got that? All right, let's go ahead and put those into the 3-box diagram. And give me one moment here. Okay, so what did we say was the upfront amount? The upfront amount. Do you remember? We said 200. And then the rate, how much is Joe going to earn for every lawn that he mows? His rate is $20 per lawn. And then the total, we don't actually know. So most of the problems that we've been working with so far, we knew this number, but we didn't know maybe how many lawns he had to mow. But we don't know this number now. So we're going to take this, we're going to put this into an equation. But instead of only having one variable, we're now going to have two variables. So we need to have a variable for how many lawns he's going to mow, and then that will impact our output variable or our total. This is going to be our total. Okay. Now let's talk about these two variables really quickly. I've already kind of mentioned them. One is called the input variable. And the input variable is usually the x variable. Okay, the x variable. And it's used for plugging in. We want to plug in various amounts into the equation. So this is where we plug in. That's why it's called the input. We're putting it in, input. And then over here, the y variable is the output variable. It represents the total after the calculations. So this is the output. It's coming out, the output variable. Okay. So we've got the input variable and the output variable. The x is our input. The y is our output. Okay. All right. And then this is really important. The input category. So we have to know, well, what are we talking about? What are we actually plugging into? We know that we're going to put it right here, but what does that represent? Well, the way we know that is the input category. In this case, it happens to be lawns. It always comes after the word per. It always comes after the word per, right? So for example, per lawn, right? He's going to make $20 per lawn. And so we know that we're going to be plugging in to the x, that's going to be the number of lawns is what we're looking for, per lawn. And it's always the word that comes after per, always, okay? All right, so now let's go ahead and set this up. The next part of our strategy is what I call an input-output T-chart. So we're going to set up an input-output T-chart. And it's going to look like this. You can go ahead and just copy this information down right here. So we're going to put the equation right here. So our equation was he has $200 saved up front, plus this is our rate, 20 times x. That's going to be our input. And then over here is our output. Okay. Now, in this particular problem, it asked us to find out how much money he would have saved for 10 lawns, 15 lawns, and 20. So if you notice, I've got those written in there. We'll do them one at a time. So 10, 15, and 20. So we're going to plug those in one at a time. So let me drop this back down. All right, so on this first one. So we're going to plug in. You can see I've got, we're going to plug it in, or as Snoop Dogg says, we're going to drop it like it's hot right in there. Okay, so we've got 200 plus 20 times 10. So 200 plus 20, we're dropping in or plugging in 10. We're dropping that in. So 20 times 10. So that's going to give us 200 plus 20 times 10 is 200. So that gives us $400. $400. And then over here, we're going to complete the T-chart, and we can go ahead and fill that in right here. So these go together. So 10 lawns is $400 of savings. 10 lawns, $400 of savings. Okay, now let's check. Let's find out how much you'd have saved if it's 15 lawns. So for 15 lawns, we're going to go here. Here's our 200, our upfront amount, starting amount, $20 for every lawn, 15 lawns. So 20 times 15, that comes out to 300. And so that would be a total of $500 saved. So 5 more lawns is $100 more. Okay. And then we can go ahead and put those numbers over here. 15 lawns will give us $500, right? That's an extra 5 lawns. We wanted to do another 5 lawns. Let's see what this is. Can you anticipate what that number will be? If this jumped by 5 and this jumped by 100, if we jump by 5 here, then hopefully that's going to jump the same. So let's find out. So if we go 200 So 200 plus 20 times 20. 20 times 20 is 400. So that's going to be a total of 600. So it jumped by 100 again. Okay. So this is called a T-chart. All right. We're setting up an input-output T-chart, an input-output T-chart, an input-output T-chart. So let me go back to there, give you a moment just to finish copying all of that down. And now let's go ahead and do an example together. So here we go. Got that? All right. So now let's do one more example together in this lesson. So on this example, we're going to be buying a car. Okay, so Joe was buying a mountain bike, and now we want to look at buying a car. So now we're a little bit older and we want to buy a car. Okay, so you'd like to buy your first car. You have $200 saved, just like Joe. He had $200 saved. So, but you have a part-time job and you make $110 per week at your part-time job. So let's say that you're going to take that money and you're going to put all of it in your savings. Okay, so here are the questions. Answer the following questions, show your calculations in the space below. So how much money will you have saved after 5 weeks? How much money will you have saved after 12 weeks? And how long will it take to save $2,400 for a down payment for your first car? So you're going to buy this old car. It's not real expensive. You want a down payment of $2,400. Okay, so we want to find out how much will you have in 5 weeks, how much will you have in 12 weeks, and how long will it take to get to there. All right, so let's go ahead and fill in our 3-box diagram. So what's our upfront amount? So our upfront amount is 200, and our rate is 110 per week. Now, for our total, I have a question mark, just like in the mountain bike, because we don't really know yet the total savings, right? This could change. That's why we're going to use a variable, because the number could change depending on how many weeks we've been saving. So now let's take those 3 boxes and let's turn those into an equation. Before we get there, let's just talk about the rate really quickly. So the rate is 110 per week, and our input category is going to be the number of weeks, right? It's the word after per week. So we know we're going to be plugging in. Our input is going to represent the number of weeks, and our output is going to represent the total savings, which right now we don't know because it could change, right? We don't yet know the total savings. Okay. All right. So now let's take those and let's go ahead and put those into an equation. And I just brought them straight down and put them right into the input-output chart. So here is our upfront amount. This is our rate. Here's our input, the number of weeks, and this is our output, the savings. And in this problem, they asked us to find the values for 5 weeks, 12 weeks, and then how long it'll take for $2,400. So here we go. Let's go ahead and start with the 5 weeks. So I'm going to take 5, go ahead and plug it in over here. I'm writing out all my calculations to get full credit. And so we've got 200 and then 110 times 5. 5 times 11 is 55. Add the 0 on the end. So you're going to get 550. So that's going to come out to a total of 750. 750. Okay. All right. Let's move on to the next one. The next one is, you can go ahead and draw your little black squiggly line. And on the next one, we've got 200 is our upfront, but now we're substituting in or plugging in 12. So 12 times 11, hopefully you know your 12's times tables, that's 132. Add the 0 on the end. So 1,320 plus 200 comes out to 1,520. Okay. Now, let's just take a guess on how much it would take to get 2,400. I'm going to show you another way to do it, but let's just take a guess. So if I took a guess, I'm going to guess 20 weeks. Let's just find out how close we are on 20 weeks. So if we plug in 200, here's our 200 to start with, and then we plug in 20 weeks. So 20 weeks, so 110 times 20. So 2 times 11 is 22, and now we have 2 zeros. Add those onto the end, so we get 2,200. So 200 plus 2,200, look at that. It came out to 2,400. Okay, so I just took a guess, and it turned out to be 20 weeks. Now, how long is 20 weeks? 20 weeks is actually approximately 5 months. So it looks like it would take us approximately 5 months, right? Usually there's about 4 weeks in a month. So 20 weeks would be about 5 months. Now, let's go, before we move on, let's go and put this into our T-chart over here on number 16. So we're going to take these numbers right here. These are pairs. They're paired up. 5 goes with 750, 12 with 1,520, and 20 with 2,400. And let's go ahead and just list those right there. So those are your numbers right there. So 5 with 750, 12. If we plug in 12 weeks, we get 1,520. And if we plug in 20 weeks, we get 2,400. Okay. So we've got those numbers right there. Now, the next thing that we're going to do is, we're going to get into this more in depth in the next few weeks, but I'm going to give you a little preview, is the next thing we're going to do is we're going to actually graph these results. So let's go ahead and do this, and I'll show you how to graph these results. So to graph these results, we want to first fill in our information. So this just came from number 16. So we've got our weeks in our savings. So 5, 12, and 20, 750, 1,520, and 2,400. And now let's go ahead and fill in our X and Y axis, because remember, these are the X values, they represent weeks, and these are the Y values, they represent savings. So go ahead and do something like this right here. So go ahead on your savings. So this was 0 down here. This is 0. And then we know we're going to need the number 200. So I just went 500, 1,000, 1,500. So I jumped by 500s. Those are our savings. That's the Y-axis. And we're going to need that 200 in a moment, because that's how much we started with. And then for weeks, let me move this up a little bit. For weeks, I jumped by 4s. So here's 0. I went 4, 8, 12, 16, 20, 24. And you could keep going. This is on the X-axis. This is our time, weeks. Okay, now we're going to go ahead and fill in. So we said at 5 weeks, so here's 4, so one more over is 5 weeks. We said at 5 weeks, it would be $750. So if this is 500 and this is 1,000, 750 would be halfway. So I'm going to go up, I'm going to go over, and I'm going to make a point right there. So there's my point. So I went up and I went over. Okay, or you can go over and down, however you would like to think about it. But we're going at 5 and at 750. And then the next one was at 12 and 1,550. So just slightly above 1,500. So 1,520, 1,520, go over and then down to 12. And then you're going to make a point, right, where those meet. And we're just doing this by hand. We're not using a computer. I did use a ruler to draw those, but you're just kind of eyeballing it. And so it should just be kind of close. And then we said 20 weeks. 20 weeks. So I'm going to go up from 20 and I'm going to go over from 2,400. And then I'm going to have those 3 points and then I'm going to draw the line. So the line was already there. I put the line there. But really what you're supposed to do is have put your point, put your point, put your point. Now remember, we're starting at 200. We're not starting at 0. And the reason we're not starting at 0 is because we had $200 saved. We had $200 saved. Okay, so I'm going to line those up, draw my line with my ruler, take out my ruler, draw my line, and now I have this information graphed. I have graphed information, and it's a linear straight line, right? Linear straight line. This is linear. Okay. All right, linear. Okay, now the final thing that we're going to do is we're going to go back and I'm going to show you a different way to find how long it would take to reach 2,400. So we just guessed at it, but I'm going to show you a different way to do it. So this is our final part of these notes. So the question is, how long will it take to save 2,400? Well, we already figured it out, but let's pretend that we had not. So the way we would do this is we would still work with our upfront amount, our rate, and our total. Okay, so we would work with those, and we've got 200 is our upfront amount. Here's our rate, 110 times X. But now we know the total. How long will it take to reach 2,400? Well, we know that total. So we're plugging it in. The only thing we don't know is how many weeks it's going to take. So that's what we're now trying to figure out. So instead of having 2 variables, we only have 1 variable. So, and the reason is because we already know this. So we're plugging that in. Okay, so here we go. So I'm going to bring that down and make an equation out of that. 200, 110 times X, 2,400. Going to subtract 200 from both sides. These cancel. I'm going to get 110X. I'm going to subtract here, and that's going to come out to 110X is equal to 2,200. Now I'm going to divide by 110. Now what I did was these 2 zeros on the end, I canceled those out, and 11 goes into 22 2 times, and then I have a 0. You could come over here and use your calculator if you wanted to. If you're going to do it on your calculator, you would put in, on your calculator, you would go 2,200 divided by 110, and that would give you 20. Now, what are we talking about? What is X? What does X represent? You remember? X represents the number of weeks. So it will take, I said Joe, it's not Joe, I forgot, it's us. We're the ones that are saving the money, but I said it would take Joe 20 weeks to save $2,400. So it's really us. It'll take us 20 weeks. Okay, so 20 weeks to save 2,400. So we just answered the question. So the question is, how long will it take to save 2,400? It will take 20 weeks. Okay, all right. Let me flip back over really quickly and talk to you. Okay, so we are working on linear equation word problems. So far I have taught you the 3-box diagram. Today I introduced the input-output chart. So these are input-output equations or input-output word problems. And the actual official mathematical name is, it's called a function. So we're going to be getting to that. I don't like using that word right away because it's kind of a little bit of a confusing word. So I like to call them input-output equations. Okay, so input-output equations. Go ahead and finish up those notes and go ahead and turn those in, and I will see you at the next class. All right, I'll see you guys.